here we have to integrate x e to the 6x dx. I want you to make an attempt at this one, and then after that you watch the rest of the video. Okay, finished? Alright. Now, what we have is an integral of two functions multiplied together. Let's use integration by parts to work it out. Remember the integration by parts formula? The integral of u dv, where u is a function and dv is another function, right? Integral of u dv equals uv minus the integral of v du. Okay? In this case, what you have is the integral of f of x, g of x dx. Two functions multiplied one another. Now, the question is, which one are you going to use as u and which one as dv? Remember, to go from u to du, you differentiate. Now, which one of them, when differentiated, give you a simpler function or a constant? It is x, alright? If you differentiate e to the 6x, you're going to have 6e to the 6x, which gets you into more trouble because it's more complicated than when you started. But when you differentiate x, you get 1, which is a lot simpler. So what we have, let's put it together like this. The integral of u dv, we'll write the relevant functions under these, equal u v minus the integral of v du. Alright? So, the integral of u dv, u is x, dv is e to the 6x, equals u remains x. Now, to go from dv to v, you have to integrate. Right? Now, the thing is, when you integrate e to the 6x, you're going to get 1/6 e to the 6x. If you're practicing integrating e to a constant times x, you're practicing enough, you would know that. But here, how it really works is an integration using substitution. If you say the integral of e to the 6x dx, and then you say let u is equal to 6x, so the u by dx would be 6. So the dx would be equal to the u over 6. Then what you would have is the integral of e to the 6x equals, no, the integral of e to the 6x, right, would be equal to the integral, or dx, would be equal to the integral of e to the u du over 6, which is e to the u du, 1/6 e to the u, because when you integrate e to the u du, you get back e to the u. But u was 6x, so it's really e to the 6x, alright? So that's really what happened. 1/6 e to the 6x. Remember that when you integrate e to the ax dx, you're going to get 1 over a e to the ax. That's the form that you're going to get. Alright? So back to what we were doing now. We have integral of u dv equals u v minus the integral of v, which is 1/6 e to the 6x. The u, we want to go from u to the u. So we differentiate. When you differentiate, you get x, you get 1. So it's times 1. Now this is equal to 1/6x e to the 6x. See that? Minus. Now, you're going to integrate e to the 6x again. So it's 1/6, the original 1/6, times, when you integrate e to the 6x, you get 1/6 e to the 6x. See that? So, what you have here now is 1/6 x e to the 6x minus 1/36 e to the 6x plus c. So that would be your solution. You can rewrite it as x e to the 6x over 6 minus e to the 6x over 36 plus c. And you can even factorize it, this part, if you want. You would have e to the 6x divided by 6. Then you have x minus 1/6 plus c.